So the first thing that we do is we work out the total Ecmon transport, just ignoring the directions altogether. Just a reminder, under the action of a frictional force that comes from the wind stress, that's provided by the wind stress, okay, the wind blows along the surface, creates friction with the surface, and the consequence is the development of Ecmon layers. Okay? The Ecmon layers, what's involved in Ecmon layers is the frictional force and the Coriolis force. Okay? That sets up these Ecmon layers. And the special feature of Ecmon layers is that the direction of the net movement from the surface to the bottom of the Ecmon layer is perpendicular to the wind direction. Okay? And you can also work out what is the total transport. Okay? We're talking about the volume transport, and this can be expressed as cubic meter per second per meter length along in the direction of the wind stress. Okay, this is what we call Ecmon transport. And so there's a formula, and the details of what happens in the water column and in the ocean actually doesn't matter. So like turbulence or so, the total transport only depends on the magnitude of the wind stress, and then it's modulated through essentially only the geographical latitude. Okay? So let's see what's written here. So first of all, these vertical lines in this formula here mean magnitude. What it means is if the number is positive, you keep it positive. If it's negative, you convert it to a positive number. This is what we call by magnitude. Okay? So it's just a number. Okay, not a vector, nothing, not the number. Okay? Magnitude of the wind stress is this Greek letter tau here. Okay? And then you have to divide it by the seawater density. And seawater density is pretty constant. So you can use 1028 kilograms per cubic meter. Okay, because if you just change it by 1 unit, the resultant change will be very small to your calculation. So you can use a constant number. And the F is the so-called Coriolis parameter. And the Coriolis parameter is positive in the northern hemisphere, negative in the southern hemisphere. Here we take the magnitude. Doesn't matter which hemisphere you are. However, you can't use the equator. There is no Coriolis force, and the Ecmon transport, this formula just blows up at the equator. Okay, so it doesn't apply to the F you can calculate. Okay, and there's a little formula here is of how you calculate the F. And F is related to 2 times this capital omega here, which is a constant. Okay, it's 2 pi over the seconds in a day. And then the sign of the geographical latitude in radians. Right? This is the so-called Coriolis parameter that modulates the Ecmon. And this is step 1, and you already learned how to work out the magnitude of the wind stress. So if I give you a wind stress vector, you can work out the magnitude of it. Again, you plug it in, you can work out the total Ecmon transport. This is step 1. Now we come to step 2.